Alright, so this LeetCode question is called square root of x. It says compute and return the square root of x, where x is guaranteed to be a non-negative integer. Since the return type is an integer, the decimal digits are truncated and only the integer part of the result is returned. So if the input is 4, the output is 2, because 2 times 2 equals 4. But let's say the input is 8, the output is 2, because the actual square root of 8 is 2.82, but we need to return a whole number. So we'll take off the decimals and just return 2.
Alright, so let's think about this problem. The square root of a number is any number where, if it's multiplied by itself, equals the target value. So how many numbers could possibly, after they're multiplied by themselves, equal the number 8? We have 8 of them. 1, 2, 3, 4, 5, 6, 7, and 8. Alright, so now we have to figure out which of these numbers multiplied by itself equals the number 8. So the way we do that is by using binary search. Binary search is just a technique where you divide the data set in half and you inspect that first half. If your result is not in that first half because let's say it's too low, then you eliminate that entire half of the data set and you look at the other half of the data set. When you're in that other half of the data set, you divide that in half and then you check out both halves of that, and you just progressively keep dividing the data set in half until you found your result. So let's look at our data set, the numbers 1 through 8. First thing we need to do is we need to figure out what the midpoint is. The midpoint in this is the number 4. So we have our left half of the data set and our right half of the data set. So now what we can do is we can look at our exact midpoint, the number 4. If we square that, does that equal the number 8? No, it doesn't. It's actually greater than the number 8. So just by that, we know we can eliminate this entire half of the data set. And how do we know that? Well, if in the left half of the data set, the greatest number is already too big, then we know that if we look at the numbers to the right of it, which are even bigger than that, they're definitely going to be too big. So at first, our leftmost data point was the number 1, and our rightmost was the number 8. But now, since we've eliminated that half of the data set, our rightmost data point is now going to be the number 4. So remember, the next step in a binary search is to then divide this data set in half. The midpoint in this data set is the number 2. So it'll look something like that. Now we go with the same logic. We multiply 2 by 2. Does that equal the number 8? No, it doesn't. 2 times 2 is 4, which is smaller than the number 8. So what we can do is we can eliminate this half of the data set. So now our leftmost data point was the number 1, but now it's the number 3. So the next step again is to divide this data set in half. The midpoint in this part of the data set is the number 3. So we square 3, 3 times 3, what does that equal? It equals 9. That's already bigger than what we need because we need the number 8. So in this case, what we're actually going to return is the number right below it, which was the number 2. I know we already eliminated the number 2, but now that we've gotten to a data set where even the lowest number is too big, we just have to subtract 1 from the lowest number in that data set and return that number. So results equals 2. So let's do that one more time, but with a number where the result is actually in the data set. We're not going to have to subtract anything at the end. So we'll do the number 9. What are the possible numbers when multiplied by themselves equal the number 9? We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so left would be 1 and right would be 9. Now we divide it in half. In this case, the midpoint is the number 5. So what we do is we multiply 5 by itself, which is 25. Does 25 equal the number 9? No, it doesn't. But we know that 25 is greater than the number 9, so we can eliminate this half of the data set. So now right is no longer the number 9, it's the number 5. All right, so now that we have this half of the data set, what do? We divide this half in half. What's the midpoint in this? It's the number 3. When you multiply 3 by 3, does that equal the number 9? Yes, it does. So that's the results. Results equals 3. Okay, let's start out with the function that LeetCode has given us. It's called mySquareRoot, and it can accept a parameter x, and x is the number that we have to find the square root of. All right, so let's start. First things first, we need a left and a right variable. So left is going to be 1, so let left equal 1, and let right equal whatever x is. Oops, misspelled right. Okay, so in this case, left is 1, right is 10. Next, we actually have to eliminate a couple of possibilities. We know that x cannot be a negative number, but x can be 0 or 1. We can immediately just return 0 or 1 if we get those, because we know that 0 and 1 are their own square roots. So 0 times 0 is 0, and 1 times 1 equal 1. So we can just say if x is less than 2, we can just return x. So if we pass in 0, 0 times 0 is 0, that's the answer. If we pass in 1, 1 times 1 is 1, so that's the answer. But if that's not the case, we know that we have to use a binary search to find the answer. So to do that, we'll use a while loop. We'll say while left is less than right, what do? First thing we have to do is to find the midpoint. So I'll just write a formula down real quick for the midpoint, and then I'll show you exactly how it works. So let mid equal left plus math.floor of right minus left divided by 2. All right, let's take 10 as the example. That formula would mean that left would be 1 plus right minus left, so we know right is 10, so 10 minus 1, divide that by 2, and round it down. So that's 1 plus 9 divided by 2, which gives us 1 plus 4.5. You round that down to 1 plus 4, 1 plus 4, which equals 5. So the midpoint for this is the number 5. Now let me just get rid of all of that. Okay, now we have our midpoint. So what's the next step? We multiply our midpoint by itself, and we check to see if that equals the target. So if mid times mid equals x, so if 5 times 5 equals 10, what would we do? We would return the midpoint. But is that the case in this example? No, it's not, because 5 times 5 equals 25. It doesn't equal 10. So what's the next step? We say else if mid times mid is greater than x, which is the case for this, we eliminate the right half of our data set. So we make right equal to mid. And that'll look like this. Right now is going to be 5, which effectively eliminates this half of the data set. Oops, I just realized that these should be inside of the while loop. Okay, so we've gone into that else if statement, which means that the while loop will start over. So what's the first thing we have to do in the while loop is, again, find the midpoint. So the midpoint in this case, if you use the formula that we talked about before, would be the number 3. So what do? You multiply 3 by itself and see if that equals the target. Does 3 times 3 equal 10? No, it doesn't. It's smaller than 10. We could eliminate this half of the data set. So now left will be the number 4. And in the code, that looks like this. Else, if mid times mid is less than x, then we make left equal to mid plus 1. Okay, so now we go to the next loop. What's the midpoint of 4 and 5? It's 4. So you multiply 4 times 4. Does that equal 10? No, it doesn't. It's actually greater than 10. So now we know that we've gone one element too much. 4 times 4 is 16, so we'll have to go down one element to the number 3, because at least that is less than the number 10. So after all of this, we return left, which is the number 4, minus 1. So let's run the code. That works. We'll submit it. And that works. All right, so our answer is faster than about 58% of other JavaScript submissions. But let's talk about big O notation real quick. So when it comes to space complexity, this has a space complexity of O of 1 because we didn't add any additional data structures. But in terms of time complexity, this is O log n because with every loop, we have halved our data set. All right, so as usual, the code and written explanation are linked down below. See you next time.